Welcome to Summarize Science. Today, we're diving into a paper that could give almost any pair of cameras powerful, human-like 3D vision. It's called Lite Any Stereo, and it's a huge step forward in making AI that can see and understand depth efficiently. The big problem in this field has always been a trade-off. You could have AI models that were very accurate at judging depth, but they were massive, slow, and needed a supercomputer to run. On the other hand, smaller, faster models just weren't very good, especially when put in a new environment they weren't trained for. Lite Any Stereo breaks this rule by being both incredibly light and highly accurate, with a special talent called zero-shot generalization. This means it can accurately perceive depth in completely new scenarios without any extra training, making it practical for real-world use. A key part of its success is a clever architecture that combines two different ways of processing information, getting the best of both without being computationally expensive. But the real magic is in how it's trained. The researchers used a unique three-stage training strategy. First, the AI learns the basics on millions of perfect, computer-generated synthetic images. Next, it goes through self-distillation, where a teacher version of the model, fed clean data, teaches a student version how to handle messy, perturbed data, making it much more robust. Finally, it's fine-tuned using a massive dataset of real-world images from the internet, using labels generated by a much larger, more powerful AI to learn the nuances of reality. The results are staggering. As the authors highlight right on the front page, this model can process 4K stereo images at 21 milliseconds on a GTX 1080, a graphics card that's several generations old. When compared to other methods, the story gets even better. This table shows that Lite Any Stereo consistently outperforms all other efficient models across 4 different real-world benchmarks. It even achieves results comparable to massive, state-of-the-art models that require over 100 times the computational power. And you don't need to be a data scientist to see the difference. In these side-by-side comparisons on tricky real-world images, you can see how other models struggle with reflections or blurry textures. In contrast, Lite Any Stereo produces clean, sharp, and geometrically accurate depth maps, consistently preserving the structure of the scene. So, let's recap the important points. The researchers created a stereo matching model that is extremely fast, lightweight, and requires very little power. Crucially, it has strong zero-shot performance, meaning it works great right out of the box on new and diverse data. This breakthrough could be huge for the future. It means we could see more advanced and affordable drones that can navigate complex forests, smarter home robots, and more immersive augmented reality applications. By democratizing high-performance 3D perception, Lite Any Stereo paves the way for powerful AI vision on everyday devices. Thanks for watching Summarize Science.